So hi, one on present here. I am Neelav Bhatiya, and I gave my JEE in the year of 2020, wherein I secured a rank of 1755. So in the previous sessions, we were discussing sequence and series, and we had taken up exercise 8.2. It was, and we had seen up until 25 questions. So moving further, we are going to see all the remaining questions of this exercise in this session, and we are going to be completing it. And in the coming sessions, we are also going to be completing this chapter. Before I actually move on and start with the exercise, I will be just going over what we have discussed. We have discussed all the formulas related to APs, all the formulas related to GPs, and how they are going to be applied to solve algebraic questions that could be asked off of these varied concepts. And this was the gist of the discussion up until now. And moving further, let us not waste any more time and jump straight to the exercises that we are going to discuss today. So we had seen about 25 odd questions in exercise 8.2, and starting today, we are going to see the rest of them. We are going to now begin our session, and the first question that we are going to be seeing is in exercise 8.2, question number 26, right? So in question number 26, we have been asked that we are required to insert two numbers between 3 and 81 so that the resulting operation is a GP. Let us say that 3 is the first term of my GP. Let us note that by A, right? So the next term of my GP, let's say X, would be AR, correct? Y, another term in this GP itself, is going to be AR square, and 81 is going to be the fourth term in this GP, is going to be AR cube, correct? So when you insert two terms which are X and Y inside the sequence, inside 3 and 81, the GP that you're going to get is AR square and AR cube, right? So now we know that A equals to 3 and AR cube equals to 81. If we were to find the values of R, then we will be able to find the values of X and Y also, because we already know the value of A, and which is 3, right? So let us divide this. Let's divide 2 by 1. Doing that, what we obtain is AR cube upon A is equal to 81 upon 3. Simplifying this, A and A gets cancelled, but you are left with this R cube, and the RHS what comes out is 27. R would then equate 3, because we are only talking about real roots, not imaginary roots. So R's value is 3, right? The first term of the GP is 3, A is equals to 3, and the common ratio is also 3. So the GP is 3, then 3 into 3, that becomes 9. Then 9 into 3 becomes 27, and 27 into 3 becomes 81. So X equals to 9 and Y equals to 27. These are the two terms that you're going to insert in this G, insert between 3 and 81, so that this entire sequence becomes a geometric progression, correct? Moving on, in the question number 27, we have been asked to find the value of n so that A raised to power n plus 1 plus B raised to power n plus 1 divided by A raised to power n plus B raised to power n may become the geometric mean between A and B. So the two numbers that have been given to us are A and B. The geometric mean between any two numbers is going to be of the form root AB, where A and B are the two numbers inside. Two numbers we're talking about, right? The geometric mean is root AB, correct? We have been said that A raised to the power n plus 1 plus B raised to the power n plus 1 upon A raised to the power n plus B raised to the power n should be the geometric mean between A and B, right? So we need to find the value of n for this particular equation, correct? Let us see how we're going to solve this, right? So the first thing that I see when I see this equation is that on the RHS, the terms are expressed inside the symbol root, right? So let us, what we should do here is we should try and square both sides, right? So let's do squaring on LHS and RHS, right? And let's see what we get then. So in the LHS, you would have a raised to the power n plus 1 plus b raised to the power n upon a raised to the power n plus b raised to the power n whole square. And now on the RHS, you have AB, right? Because root EB squared is just AB. So what you are now left with is, let us cross multiply a raised to the power n plus b raised to the power n, the whole squared on both the sides, and see what you are left with, right? So what we now get is a raised to the power n plus 1 plus b raised to the power n plus 1 whole squared equals to AB a raised to the power n plus b raised to the power n whole squared. Correct. Now opening up the terms inside the square. So what we are now left with is a raised to the power 2n plus 2. I have done nothing but I have just multiplied I have multiplied n plus 1 into 2 plus 2 times a raised to the power n plus 1 b raised to the power n plus 1 plus b raised to the power 2n plus 2 equal to AB. Inside the bracket becomes a raised to the power 2n plus 2 a raised to the power n b raised to the power n plus b raised to the power, b raised to the power 2n. Correct. This is what it becomes. Moving on, let us multiply AB into the bracket and see what we get. So on the LHS side, it's going to be the same. It's going to be a raised to the power 2n plus 2 plus 2 a raised to the power n plus 1 b raised to the power n plus 1 b raised to the power 2n plus 2 equal to a raised to the power 2n plus 1 b plus 2 a raised to the power n plus 1 b raised to the power n plus 1. So AB multiplied by this term right here becomes this. And finally we get b raised to the power 2n plus 1 b. Correct. So the first and foremost thing that I see is can cancel 2 a raised to the power n plus 1 b raised to the power n plus 1 from the LHS and from the RHS, right? So when you do that, what you're left with is a raised to the power 2n plus 2 plus b raised to the power 2n plus 2 equals a raised to the power n plus 1b plus 2n plus 1b plus b raised to the power 2n plus 1a. Correct. Now, what you now do is you take b raised to the power 2n plus 2, write up and take that term into the RHS and take this term a raised to the power 2n plus 1 into b in the LHS. Why should you do that? You should do that because you'll be able to see that in here you can take a raised to the power 2n plus 1 common from this and this term. And you can take b raised to the power 2n plus 1 common from this and this term, right? So let's do that. So in the LHS, you get a raised to the power 2n plus 2 minus a raised to the power 2n plus 1b. And on the RHS, you get a b raised to the power 2n plus 1 minus b 2 a raised b raised to the power 2n plus 2. Right. On the LHS, you can take a raised to the power 2n plus 1 common. When you do that, you get a raised to the power 2n plus 1. What is left with is a minus b. And on the RHS, you can take b raised to the power 2n plus 1 common. what you're left with is a minus b. Subsequently, you can cancel a raised to a minus b off from LHS and RHS and take b raised to the power 2n plus 1 in the denominator, right? So you get a raised to the power 2n plus 1 upon b raised to the power 2n plus 1 equal to 1. Right, I've done nothing but I've taken b raised to the power 2n plus 1 into the denominator on the LHS side. And when it equates 1, we can say that ab raised to power 0 equal to 1, right? So, can we say that a upon b raised to power 2n plus 1 equal to a upon b raised to power 0 equals to 1, right? Because 0, anything raised to power 0 is going to be 1, right? So, can you say that 2n plus 1 equals to 0? Correct. Can you say that? So, n equals minus 1 by 2. So, for the value of n equals minus 1 by 2, a raised to the power n plus 1 plus b raised to the power n upon a raised to the power n plus b raised to the power n is going to be the geometric mean between two numbers. Correct. So that was the solution. Moving on. Now we are going to be solving question number 28. Right. So in question number 28, we have been told that the sum of two numbers is 6 times their geometric mean. Show that the numbers are in the ratio are in the ratio 3 plus 2 root 2 ratio 3 minus 2 root 2, right? So let us suppose that these numbers are going to be a and b, right? We have been told that the sum of these two numbers, so let's suppose this is a plus b, is going to be equal to 6 times their geometric mean. And what is that? It's 6 times a, right? So from this equation, we know that 6 plus a plus b equals to 6 root ab, correct? Now, when this is equal to this, you can say that a plus b whole square is equal to 36ab, correct? I've done nothing but I have squared up both sides, right? So what would a minus b whole square become? So a minus b whole square in a general term is going to be a plus b whole square minus 4ab, correct? Can you see this? Why would this be? This is going to be equal to this because a minus b the whole square, and you expand that, you get a square minus 2ab plus b square, and that is 4ab less than a plus b the whole square, right? So plugging the values of a plus b the whole square and from above, you get a minus b whole square equal to 36ab minus 4ab, correct? So a minus b whole square equal to 32ab. Taking the root on both sides, you get a minus b equal to root 32ab, correct? Now this is nothing but root 32 root ab as well, right? Now this is root 32 is nothing but 4 root 2, correct? So a minus b is going to be 4 root 2 root ab, and also we have a plus b as being equal to 6 root ab. So to find out the values of a, what I'm now going to do is I'm now going to add these both equations up, right? So doing that, I now have 2a equals to 4 root 2 root ab plus 6 root 2 6 root ab. Dividing both sides by 2, you get a equals to 3 plus 2 root 2 into root ab. Correct. Plugging in this value of a, into the first equation, you get 3 root ab plus 2 root 2 root ab plus b equals 6 root ab. Right, taking everything except b onto the RHS, you get b equals to 3 root ab minus 2 root 2 root ab. Taking root ab out common, you get 3 minus 2 root 2 root ab. Correct. So now we have the values of a, and we also have the values of, now we have the values of a, which is right here, and we have the value of b found right here. Find out the ratio of a and b. Let us divide a by b and let's see what we get. Right. So a ratio b equals to a upon b equals to 3 plus 2 root 2 ab upon 3 minus 2 root 2 root ab. Correct. Root ab and root ab gets cancelled. What we are finally left with is 3 plus 2 root 2 upon 3 minus 2 root 2, and we had been asked to do that itself and we did. Right. So that is your final answer. And yeah, that was question number 28 for you guys. Moving on. So moving on, we solved question number 28. Let's try and see what question number 29 tells us. All right. In question number 29, we have been asked if A and G be the AM and GM respectively between two positive numbers, prove that the numbers are A plus minus under root A plus G into A minus G. Correct. Let us assume that these two positive numbers are going to be A and B. Right. We have been told that their AMs and GMs are respectively A and G. Right. So AM, which is the arithmetic mean of two numbers, is going to be A plus B by 2, and that is A. Right. So A plus B equals to 2A. Correct. Now we have been said that the geometric mean is going to be G. Right. So root AB is going to be G. So AB is going to be G squared. Correct. So A plus B is equal to 2A and root AB equal to G square. We are going to apply the same technique that we used in the previous question. We are going to say A minus B whole square equals A plus B whole square minus 4AB. Correct. So A minus B whole square is A minus B whole square is going to be A plus B whole square, and that is nothing but 4A squared, because A plus B is equal to 2A, and in here you have minus 4G squared. Correct, because root AB we have found out that AB is equal to G squared. Correct, because root AB was G. So A minus B whole squared is going to be 4A square minus G square. Correct. Now A square minus G square can be written as A plus G into A minus G. Correct. So A minus B the whole square is going to equate to 4 A plus G into A minus G. Correct. Now taking the root on both sides, you finally get A minus B equal to 2 under root of a plus g into under root of a minus g. Correct. So a minus b is 2 root a plus g root a minus g. Correct. And we have also found out that a plus b is nothing but 2a. Right. Adding both these equations up, you get b and b gets cancelled. You get 2a equals to 2a plus 2 times under root of a plus g into a minus g. Right. Now you can cancel. Now I have the values of a. You can plug this value into first equation, a plus b equals to 2a. And what you then get is a plus under root a plus g, a minus g plus b equals 2a. Therefore, b equals a minus under root of a plus g into a minus g. Correct. So now you have the values of b. You have the values of a right here as well. And as you can see, a and b would be written as a plus minus under root of a plus g, a minus g. Correct. So yeah, that was what was asked of us. We had to show that two positive numbers and their AM and GM would be expressed as this. Right. That was it. Moving on. The question number 30, it tells us that the number of bacteria in a certain culture doubles every hour. Doubles every hour. If there were 30 bacteria present in the culture originally, how many bacteria will be present at the end of second hour, fourth hour, and the nth hour? Right. So it has been told that it doubles every hour. Right. Originally, the bacteria were 30. Right. So we can say the first number in the series is going to be 30. Right. As the bacteria double every hour, so at the end of the first hour, we can say that the bacteria inside the culture are going to be 30 into 2. Correct? How did we get there? Because we have been told that they double every hour. At the end of first hour, they are going to be 30 into 2. At the end of second hour, they are going to be 30 into 2 into 2. Correct? And so on and so forth. When you do this, you are going to be able to see the pattern inside this series. The pattern that you see here is that the first term is 30, the common ratio is 2, and the entire sequence forms a geometric progression. Correct? So the question now will be at the end of second hour. So the first at the 0th hour, the starting, you have 30 bacteria. At the end of second hour, you have 30 into r. At the end of first hour, you have 30 into 2. Right. At the end of second hour, you have 30 into r square. Right. This is at the end of second hour. So at the end of nth day, you are at term n plus 1 term, which is going to be a raised to the power n. This is the equation that you are going to follow for this particular question. Right. So for the end of second day, you have third term in the GT, and that term is going to be 30 r square, and that is nothing but 30 into 2 square. Right. 2 square is nothing but 4. 30 into 4 is 120 bacteria. Right. At the end of fourth hour, you are going to have the fifth term, and that is going to be 30 into 4 raised to the power r 4 r raised to the power 4. We have 30 into 2 raised to the power 4. 2 raised to the power 4 is going to be nothing but 16, and 16 into 30 is going to be 480 bacteria in the culture after the end of 4th hour, right? After the end of nth hour, we have already found out the formula. You have n plus 1th term, and that is certainly going to be 30 into r raised to power n, and that is going to be 30 2 raised to power n. These are the number of bacteria inside a culture after the nth hour, right? Very straightforward question, just an application of geometric progressions and deriving the formulas that we get from it. That is how you solve this question, right? Moving on, question number 31. We have been asked, what will 500 amount to in 10 years after it deposits in bank which pays annual interest of 10% compounded annually? Correct. So the amount that we are going to deposit, the principal is going to be 500, right? And so let's do this, right? So on the 0th year, at the start of 0th year, or at the March 0th year, we deposit 500, right? At the end of first year, you receive an interest of 10%. So your amount 500 plus will become 500 into 0.1. And that is nothing but 500 to 1.1. At the end of second year, your amount at the end of first year gets compounded again, right? So now you get 500 into 1.1 into 1.1 again, because the interest is generated upon this amount and the principal is this amount, right? Similarly, at the end of third year, you have 500 into 1.1 into 1.1 into 1.1. The pattern here is that the amount is also in a geometric progression. At the end of nth year, you would ideally have 500 into 1.1 raised to power n, right? So at the end of 10th year, which is the question that is asked of us, the amount that it will become is going to be 500 into 1.1 raised to power 10, right? So that is our final answer, correct? Moving on, if the AM and GM of roots of a quadratic equation are 8 and 5 respectively, then obtain the quadratic equation, right? So question number 32 tells us that the AM and GM of roots of a quadratic equation are 8 and 25, right? So A plus B, let's assume the roots to be A and B. So A plus B by 2, the AM of this equation is going to be A. So A plus B is going to be 16, correct? The geometric mean, which is root AB of this equation, is going to be 5. So squaring both sides up, you get 20. A and B as 25, right? Any quadratic equation could be expressed as x square plus sum of roots. I'm sorry, this is going to be minus here, into x plus product of roots equals 0, right? This is going to be the equation. So when you plug the values of sum of roots and product of roots into this equation, what you finally get is x square minus sum of roots is going to be 16. So you get 16x plus product of roots is going to be 25. You get 25 here, right here, equals to 0. So your quadratic equation is x square minus 16x plus 25 equals to 0, right? So this is your required quadratic equation. Moving on, we still have some time left in today's session. So without wasting any more time, we are going to jump to the miscellaneous exercise of this chapter, and we're going to see a couple of questions from that exercise as well, right? That is what we're going to do. So before starting the miscellaneous exercise, I would also reiterate here that at this point, you should be familiar with each and every formula of this chapter, because in miscellaneous exercise, it's going to see a lot of combination of concepts that are used throughout the chapter, right? So that is something that you need to keep yourself familiar with before the start of this particular exercise. And yeah, moving on, let's start with it. Right. So we are now on to exercise 8.3, or let's say the miscellaneous section. Right. So moving ahead, you get this. Right. Question number 1. If f is a function satisfying f into bracket x plus y equals f of x and f into f of y for all xy, such that f of 1 equals to 3 and summation of f of x for f x equals to 1 up and x in x equals to n equals to 120, find the value of n. Right. So we have been given that f of x plus y is equal to f of x to f of y. F of 1 is given to us as 3 and summation n equals 1, x equals 1 up until n, f of x is going to be 120, or so has been told to us. Right. So let us first plug in the values of x and y, random values of, not random, but plug in the values of small values of x and y into the equation, into the functional equation that has been given to us, and see what we get. Right. So we have f of 1 equals 3. Let us take f of 2 equal to f of 1 plus 1 equals to f of 1 into f of 1. Correct. So when you do that, this becomes f of 2 equals 3 into 3. Similarly, you have f of 3 equals f of 2 plus 1. That becomes f of 2 into f of 1. That becomes 3 into 3 into 3. Now, when you do that, you'll be able to see that this entire thing forms a geometric progression with the first term as 3 and the common ratio also as 3. Because f of 4, when you're going to find out, is going to come out to be 3 into 3 into 3 into 3. Right? So on and so forth. So we have a GP of the form a equals to 3. The common ratio is also 3. And it has been said that the sum up until n terms is equal to 120. Right. So the nth term, the sum of nth term is going to be a. R raised to the power n minus 1 upon r minus 1 is going to be 120. The first term of the sequence is 3. N is equal to 3 raised to the power n minus 1. In the denominator, you have 2 because 3 minus 1 is equal to 2. Here you have 120. Multiplying 2 in LHS and RHS and dividing by 3, you get 40. Then you multiply again by 2, you get 80. Right. So 3 raised to the power n minus 1 is going to be 80. 3 raised to the power n is going to be 81. N is going to be 4. Right. So the value of n is equals to 4. Right. This was the first question of this exercise. Moving ahead. Now we're going to see question number 2. Question number 2 says the sum of some terms of a GPA is 315, whose first term and the common ratio are 5 and 2 respectively. Find the last term and number of terms of this GP. Right. So it's a very straightforward and trivial question as of now. So the first term has been given to us as 5. The common ratio has been given to us as 2. And we have been said that Sn equals 315. Right. So the summation of n terms is going to be a r raised to the power n minus 1 upon r minus 1, and that has been told to us as 315. So a, the first term of the sequence is 5. R, we know that r is going to be 2 raised to the power n minus 1. Here we have 2 minus 1. We have 315 right here. Right. So 2 raised to the power n minus 1 equal to 315 upon 5. This gets divided. What you're left with is 63. Right. So 2 raised to the power n minus 1 is going to be 63. 2 raised to the power n is going to be 64. And the value of n for this equation is going to be 6. Right. So the value of n is equal to 6. And the first term. So we have found out the common ratio, which is R. I'm sorry, number of terms. We have found out the number of terms. Number of terms is equals to n, and that is going to be 6. The last term of the sequence is going to be a, r raised to the power n minus 1. A was 5. You have r as 2 raised to the power 2. R is 2. N raised to the n minus 1 is going to be 5. So you have 5 into 32, and that is going to be 160. So the last term is going to be 160, right? So number of terms is 6. The last term is 160, and yeah, this question is solved. Moving ahead, in question number 3, you have the first term of the GP is 1. The sum of the third and fifth term is 90. Find the common ratio of GP. Correct? The first term of the third term is going to be r square, ar square. Sorry, just let's do this. Third term is going to be a raised to the power a into r raised to the power n minus 1, and that's going to be a r raised to the power 2. The fifth term is going to be a r raised to the power 5 minus 1. That's going to be a r raised to the power 4. Right. So when you do this, you get, and a is always going to be 1. So third term is r square, and fifth term is r raised to the power 4. So we have been said that the summation of the third and fifth term is going to be 90. Right. So you have r raised to the power 4 plus r square is going to be 90, and we will not be able to solve the quadratic the equation when you have powers of 4 in the equation. So to simplify this, let's say E equals r square. Right. Let's substitute this, and then we'll be solving for this equation itself. Right. So when you do that, you get t square plus t equals to 90. You get t square minus plus t square plus t minus 90 equals 0. Right. So t square plus 10t minus 90 minus 90 equals 0. So you get t common here, you get t plus 10. You get minus 9 common here, you get t plus 10 right here itself, and you get 0 here. Right. So you get t equals to minus 10 and t equals to 9. This will get rejected because we have substituted t is equals to r square, and a square of any term cannot be negative. So this is rejected. You have t equals to 9. So r square equals to 9 and r equals to plus minus 3. Right. So the common ratio of this particular GP is going to be plus minus 3. Right. That is the final answer. Moving on, we are going to solve the fourth question now. Right. So for the fourth question, says that the sum of three numbers in a GP is 56. If we subtract 1, 7 and 1, 7 and 21 from these numbers in that order, we obtain an arithmetic progression, right? And then we have been asked to find the numbers, right? So let's suppose these three numbers to be A, AR, and AR squared, right? So the summation of these three numbers is A plus AR plus AR squared equals to 56. This is the first equation that we have. Then we have been told that when you subtract 1 from the first term, 7 from the next term, and 21 from the last term, these three numbers are going to form an AP. Correct? So then if these three numbers form an AP, the difference between this and this term and this term is going to be the same. So AR square minus 21 minus AR plus 7 is going to be AR minus 7 minus A plus 1, right? So you get AR square minus 14 minus AR equals to AR, you get AR minus 6 minus A, right? So when you take all of these terms out in the RHS, when you separate these terms out, you get AR square minus 2AR plus A equals to 8, right? Taking A out common, you get R square minus 2R plus 1 equals to 8. Now we have these two terms. Let us try and find out the value of A from the previous equation and plug in that value right here, right? When you do that, what you get is, so we have been told that A plus AR plus AR square equals 56, right? So take out A out common, so 1 plus R square equals to 56. When you do that, what you are left with is A equals 56 upon 1 plus R square. Plug in the value of A into this equation right here, and let's see what we get. You get R square minus 2R minus 1 into 1 upon R plus R square, 56, equals 8, right? Equals 8. So what you now have is 56 R square minus 2R minus 1 equals to 8 R square plus R plus 1. Right. This can be solved. You can cancel this and this out. This goes 7 times. What you're finally left with is 7R square minus 14R minus 7 equals to R square plus R plus 1. So you solve this, you get 6R square minus 15R minus 8 equals to 0. 6 into 8 is have I solved this correctly, or did I make a mistake somewhere? No. Oh, okay. My bad. I seem to have goofed up somewhere. Oh, it was +1 here, not -1. Sorry. The equation is going to be +1 here, right here, not -1. Because it's +1 right here, right? Maybe +1 right here, so it's going to be +7, and this is not going to be -8. It's going to be +6. Sorry, guys, my bad. When you do this, 6 into 6 is nothing but 36, and 36 is 12 into 3, right? That is how we're going to solve this. So this becomes 4R square, 6R square minus 12R minus 3R minus 6. Taking 6R out common, you have R minus 2, and minus 3 out common, you have R minus 2 equals to 0, right? So we have r minus 2 into 6r minus 3 equals 0. So r can either be half or r can be 2, right? Let's solve for r equals to 2 first. We have a equals to 56 upon 1 plus r square plus r. When you solve this, you have 56 divided by 7. A becomes 8. The common ratio is 2. So your terms are 8, 16, 32. Right? These are your three terms. When you have, let's solve for r equals half. For that, your first term becomes a equals to 56 upon so half. So you have 1 by 4 plus 1 by 2 plus 1. 8 is the common denominator right here. And when you do that, you have 56 divided by 7 by 8. You get, so this goes, I guess, yeah, that is what it should do. Oh, so 7 into 7 by 2, not 7 by 8 is, my bad. It's 7 by 2. So you now have 8, 7 by 4, not 7 by 2, 7 by 4. So you have 56 into 4 upon 7. This gets cancelled. This and this finally becomes 32. So your terms at the end are going to be 32, 16, and 8, which are the terms for r equals to 2 as well. So the terms are going to be the same, 8, 16, and 32. The common ratio can be 2 or the common ratio can be half, right? That is your final answer. So we have seen about 4 questions from this exercise, and the remaining questions, the remaining 14 odd questions, we are going to take these questions up in the next session that we have. And yeah, this was all from my side. So thank you.